Hi, we are a group of undergraduate engineering students taking Intro to Engineering 170.
Our project is to construct a device that will keep our client's dog from rushing to the door when he hears the doorbell.
Our client requested that we create a dispenser in order to draw her dog away from the entryway and towards his awaiting treats.
Not only will this product help our client, but it will aid the 48 million dog-owning households in keeping their pets calm and out of the way upon the arrival of guests.
Our client requested that we create a dispenser that releases about one treat at a time every 15 seconds over a span of 2 minutes when the doorbell is pressed.
After exploring our options, we decided to create a casing around the doorbell that would send a signal to the dispenser via the Bluetooth when pressed.
The dispenser we designed has a funnel shape that angles treats toward an opening at the bottom of the device. A piece just above the bottom opening with a plus sign shaped cross section will rotate 90 degrees to accurately dispense about one treat at a time. Once we designed the dispenser on paper, we put our sketch into SolidWorks so it would be ready for printing.
For the majority of the dispenser, we used PLA with the Makerspace's Ultimaker. For the front transparent piece, we laser cut 1/4-inch clear acrylic. Finally, we put all the pieces together. This included securing the dispensing component with dowels and gluing the acrylic, the male mounting pieces, and the plastic hinge with epoxy and acrylic glue provided by the Makerspace's Mini Mart. At this point, the mechanical components of the dispenser were completed. Both the dispensing and mounting pieces were successful. The next piece we had to create was the doorbell casing. Since the client wanted the system to be compatible with her current doorbell, we had to create a housing with a button that both presses her current doorbell button and also triggers an Arduino to send a signal to the dispenser. After calculating the dimensions for the casing given the existing doorbell dimensions and the space taken up by the Arduino and 9-volt battery, we put our design into SolidWorks. We then 3D printed our design using PLA with the Makerspace's Ultimaker. Next, we began working on our coding and circuits. We used 2 circuits, one for the doorbell and one for the dispenser. Arduinos on each circuit communicate via Bluetooth so that the motor on the dispenser would spin when the button on the doorbell was pressed. This is just a quick demonstration of how the doorbell casing works. So we've created this casing that can be nailed on around the client's existing doorbell. And the goal of this casing is to have a button that can both press her doorbell and also send a signal to the Arduino. Here's what the inside of the casing looks like. Back, we have a breadboard, a 9-volt battery, an Arduino, and then this other button that sends a signal to the Arduino. So this button will be taped or glued on to the client's existing doorbell button, so that when the button in the casing is pressed, it'll press both into this button and then into the doorbell button. And this will send a signal to the Arduino, which will send a signal to the dispenser, and the motor will turn.
In the end, the dispenser works well manually when you turn the dowel piece.
And both of the breadboards with the Arduino Bluetooth connection both do work.
However, when there is more than one treat in the dispenser, the motor does not have a high enough voltage to turn the rotating piece.